today, and it is just like the previous exams. It is due midnight on Saturday. The one thing that is going to be different about this exam is the previous ones, if you had some kind of a technological issue, something went wrong, it kicked you out of the exam, or you were having trouble getting to the exam in the first place, you will not be able to take the exam after Saturday. It won't. It can't happen. It's just because grades are due. I'm supposed to have my grades turned in Monday. Technically, they're due Tuesday, but if I don't have them turned in Monday, I will have people calling me, bugging me to get them turned in. And to have those turned in on Monday, I have to calculate them Sunday, and so I cannot have people changing their grades after that point, essentially, unless there is some extreme circumstance, which just getting kicked out of the exam because you waited until the last minute to take the exam would not count as that. So I would highly encourage you to not wait any later than Friday to take that exam, because you will want to be sure that you can get in and take that. Just because we're at the very end, it needs to be done. It can't be put off for several days at that point. It needs to get done. Let's see. So did everyone get the topic list that I sent out for the exam? Okay, good. I debated as to whether I should just put it on the Blackboard site. I figured that sending it out in the email would be better. So that topic list, and actually let me pull that up myself here so I can take a look at it. That topic list is a little bit shorter than I normally make it. Just because of the extraordinary circumstances of the semester, I tried to cut it down a good bit. So there are certain chapters where there's like just one thing from the whole chapter that will be on the final, and then there's other chapters where there's just 2 or 3 different topics. And if you would like, which I would assume you all would, I can go through and talk about what the types of questions that would be asked for each of those things here. No, you will have 2 hours for the final. So the hours, the final, you'll have 120 minutes. So you'll have about 30% more time, a little more than 30% more time, I guess. Or no, I guess it is. Well, it doesn't really matter. You'll have an extra 40 minutes, and the exam itself is really only slightly longer. It might not even be longer at all than the previous exams. So hopefully, fingers crossed, you will not be pressed for time on this exam. I forget exactly how many questions there are. Let me go back and check. Okay. Let's go ahead and talk about that topic list. So, the main point, I would say, of what I'm going to go over here is that anything that we've had in a online exam already. So that would be the stuff from exam 2 and exam 3, the stuff that we've already covered in an online exam. The final is going to be very similar, if not identical, to the questions that you saw over those topics in those exams. There are a few new things, though. So the first couple chapters there, intermolecular forces and solutions and kinetics. So those were covered in exam 1, which we had on campus. So we did not have an online exam over those. So you haven't seen those types of questions online before, so I'll go over those here. So for that first point there, be able to identify molecules that have dispersion forces, dipole-dipole forces, and hydrogen bonding. The way I'm going to ask those questions is I wrote out or drew on my computer, I think, 12 different molecules, I think. And I copied images of each of those different molecules, and I put them into different questions on the exam. And the question is just, here's the molecule, tell me what intermolecular forces can exist in this molecule. You will not have to do 12, obviously. I think I had you do 4. So it's the exam will randomly pick 4 of the 12 possibilities. And you will tell me whether they have dispersion forces, which, if you remember, is always correct. Whether they have dipole-dipole, hydrogen bonding, and ion dipole. And if I remember correctly, the way that I did that was it was a multiple choice question where you can pick multiple of the answers, and so there's a spot for each one of those 4, and you just select each one that is present, or that could be present in that molecule. So some of them could have just dispersion, some of them could have dispersion and hydrogen bonding, some of them could have dispersion and ion dipole, some of them could have dispersion, dipole-dipole, and hydrogen bonding. It just depends on the molecule. Yes, ion dipole is free game. It is. And so remember, the only time that I would give you ion dipole is if the molecule itself is ionic. So if I gave you something like sodium fluoride. I don't know why it picks the rainbow one every time. But sodium fluoride. I know, office hours. So sodium fluoride is ionic because you have a metal and a nonmetal. So if I give you a molecule that has a metal and a nonmetal in the molecule, that is going to be ion dipole and dispersion. But that'll be the only situation where you'll have ion dipole. If it's just a molecule that has a dipole, do not put ion dipole as an answer. Only put ion dipole if the actual molecule in front of you is ionic. Any other questions about that?
So I missed the first 10 minutes of this class. I'm sorry. This is for the final,
Yes.
correct?
Yes.
Okay. And when is it due by? Is it open today?
Yes, it became available at 9 o'clock, and it is available until Saturday at midnight. Although I would highly suggest that you get it done by Friday, because if something goes wrong, you won't be able to do it later than Saturday because I have to get my grades turned in. So,
Okay.
if you get 2 questions into the exam and something happens, you lose your internet and it's gone. There's not really anything I can do to help with that, Sunday evening, because I have to get my grades turned in the next morning. So I would highly encourage you to get the exam worked on and done Friday evening at the latest, so that way if something does happen, I can get you back in Saturday morning or something like that. Um,
Okay.
so
Yeah, I had something go wrong with my internet the last couple of days, so I'm tethering off my phone. So I'm a little nervous to take the exam until I fix my internet.
yeah, yeah. Um, so if that's still giving you issues later this week, boy, I really don't know. With the current situation and everything going on, you're really limited in terms of what you can do to get reliable internet.
Yeah, well, Sprint's okay for right now.
Okay. Yeah, depending on where you live, Sprint is not very reliable where I live.
Oh,
um,
don't tell
I
me that.
yeah, well, I live out in the country, so I used to use
Oh, okay.
Sprint. I have T-Mobile now, which, believe it or not, is actually slightly more reliable where I live than Sprint, which is kind of amazing.
Oh, oh, some of the campuses have Wi-Fi in the parking lot. Oh, catch me doing my test in my car in the parking lot. That's funny.
That is true. That they do have. They've. I think that they've like built little miniature shelters and put routers out in the parking lot.
Oh, okay.
During
Okay,
the
that's
day.
handy.
I believe they have. I haven't actually gone by and checked that, which I might be doing
Okay.
that today. So yes, we are talking about the final, and we're going to go over the topic list here. So that was you've only missed the very first one there, or I guess you jumped in the middle of the very first one. So the second group here, which is actually the third chapter we talked about, believe it or not, those first 2 chapters only have one topic that made it onto the final. But in kinetics, we have be able to use the rate law to solve for any involved parts. So the rate constant, order the reaction with respect to each reactant, and concentrations. Essentially what I'm looking for there is if I tell you, the rate is, the rate law is something like this. And I give you data on most of this stuff here. I expect you to be able to essentially do algebra is really what it's looking at here. What it comes down to is being able to solve for any part of this. So if I give you data on the rate constant, and one of the concentrations, you should be able to do the algebra to work out what the second concentration is. So it really is just algebra is what that comes down to. The second bullet point here, be able to use the integrated form of the rate law for first, second, and zero order reactions. Pretty much the same thing. If I give you information on, I don't know, let's say I say you have a second order reaction and you know the rate constant is 1 times 10 to the negative 4. If you start with a concentration of 1.5 molar, how long does it take to get to a concentration of 0.2 molar? So, something along those lines. It's very similar to what was on the previous exam, the paper exam that we did. And so in that case, you would be trying to find t, trying to find the amount of time that it takes to do that. And so you would have to go back and you would find the integrated form of the rate law, which was this. Let's see, that was kt plus 1 over. I believe that's correct. Sometimes I forget a negative sign somewhere, but I believe that is the correct integrated rate law. Okay. So that is, in a nutshell, what I would be expecting for that second bullet point there. Just being able to figure out which integrated rate law to use, which I would tell you if it's first order, second order, zero order, and then being able to plug values in and solve for any part of that. So it's mostly algebra there as well. And the same type of thing with the half-life equation for that last bullet point. Just being able to use the other equations, so like the half-life for a first-order reaction. So being able to use this either to find the half-life, or if I tell you what the half-life is, use that to find the rate constant. Just being able to use those equations. So that was for first order. If you remember, second order was 1 over k times the initial concentration. So just being able to do that is what I am looking for there. Okay, so the next, and really all the rest of these topics, those are from exams that we've had online. So we had exam 2, which was chemical equilibria, acid equilibria, and buffers. So this was exam 2, and then exam 3 was thermodynamics and electrochemistry and nuclear chemistry. Just in general here, the way that I did the exam, I think I might have made 1 or 2 new questions for, actually I know I did. I made a couple new questions because some of the topics from the previous exam, I didn't make very many questions in the first place. So some of the questions that were kind of longer questions, I didn't want to make 6 questions that took me 10 minutes to make. I didn't want to spend an hour just to make 1 question for everyone. And so I did make a few new questions. That being said, they're in the exact same format as the questions from the previous exam. And for those questions where I did have a pool of questions that I could pull from, all I did was I put the pool in to the final. So it's the exact same pool that I used for the second and third exams. I just put the same pool of questions into the final, and so you very well could see questions that you saw in the previous exams on the final. It's entirely possible. Probably won't see a bunch, won't be like half of the questions you see, but you could see 1 or 2 questions that you've actually seen in previous exams on the final. Let me see here. I don't think you can rework them. I think you can go back and look at the questions that you got on the exam. I think you can go back and see the question and see the correct answer, I believe. I think that's how they're set up. But no, you can't rework them. So I guess if you wanted to rework them yourself, no, Callie, what do you mean, did I change it? Oh, you can't see the correct answer? You should be able to see previous tests. Let me try something real quick. I'm going to stop sharing my screen for a second. Sorry about that. I was hearing weird noises. I've had issues in the past with woodpeckers trying to find things in my house. And so if there was a woodpecker trying to drill into the side of my house, I wanted to shoo it away, but I don't know what it was, but I don't think it was that. Anyway, getting back to what we were just talking about. I wasn't going to hurt it. I was just going to shoo it away. Woodpeckers are nice birds, except for when they start to drill holes in the side of my house. So for this one here, the using the Henderson-Hasselbalch, let me erase some stuff here. So if you remember the Henderson-Hasselbalch equation, we have the pH of a buffer is equal to the pKa of the buffer molecule plus the log of the base over the acid. And so you should be able to either take base and acid information that I give you and find the pH, or you should be able to take a pH value that I ask you to make a buffer for, and figure out how much base and acid you need to make that buffer. So if you're going to go that second route, I would give you a pH, and I would give you the acid that you were using, and so you would have the pH and you could calculate the pKa using the Ka. Because remember, the pKa is just the negative log base 10 of the Ka. And then I could either ask you to find a ratio, so just what ratio of base to acid would you need, in which case you would just be solving for this. Or I could ask you to find specifically one or the other. And so if I did ask you to do that, it would just be a little bit extra algebra. So you would have to get rid of that log base 10, and then you'd have the algebra of getting either the base or the acid by itself, whichever one it was that you were looking for. But that's really all you need to do, be able to do from this chapter, is just use the Henderson-Hasselbalch. So in a nutshell, it's essentially know how to find anything in the Henderson-Hasselbalch. Be able to solve for anything in the Henderson-Hasselbalch. Any questions about that? Does that answer your question, Aaron?
Sort of. I understand that the negative log Ka equals pKa. I get that, but I don't know how I would find the Ka, I guess, still. I think that's something maybe I need to review.
So when you're trying to find the Ka, I would tell you what the acid is. And then you would just go to the back of the book and find the Ka.
Okay. Okay.
Let me pull that up here. So if I were to tell you, for example, that you made a buffer using acetic acid, and you needed, I wanted that buffer to have a pH of 4. If we go down here, we have the ionization constants of weak acids. Sorry, I was hearing the weird sound again. I think it's squirrels running across my roof again. I really need to trim all the trees near my house so that they can't jump from the trees to my house. Anyway, so acetic acid happens to be the very first one here, and it gives you the Ka value. So we have 1.8 times 10 to the negative 5. And so you would then, let's go back here. If you wanted a pH of 4, the Ka was 1.8 times 10 to the negative 5. So if you take the negative log base 10 of that, you get 4.74 is the pKa. And so if I wanted to know what ratio of base to acid that I needed to use, it would be a matter of, let's see, so you'd subtract 4.74 from both sides. That will get you negative 0.74 is equal to the log of the base over the acid. Take 10, raise it to both sides, and that will give you oops. Be helpful if I did it right on my calculator. That gives you 0.182 would be the ratio between the base and the acid that you would be looking for there. And so if it was asking you for a specific one of these two, I would have to give you one or the other. I would have to give the other one, essentially. And so if I told you that I wanted to know how much base you would need given, I don't know, 0.1 moles of acid, then you would just take this number and multiply it by 0.1, and that would tell you how much base you need. So at that point, it's just algebra. So if I don't give you the Ka value in the question itself, you can always just go to the back of the book and find it.
Thank you.
Mm-hmm.
I have a question.
Yes, Melissa.
Okay, so the ratio is 0.182 on that problem. And you're saying if you gave us the acid one of O1, we would multiply that, not subtract or divide?
So if I gave you the acid, so if in the question itself it said you have an acid concentration of 0.1, what that would mean was that when you got to this point, you know that the ratio of the base to the acid is equal to 0.182. So if I'm trying to find what concentration of base I need, I would need to multiply both sides by the concentration of the acid to get the base by itself. So my acid would cancel out here.
Okay, I get it. Sorry.
Yeah, no problem. No problem at all. So then if it was 0.1, then it's just, let's see, that would end up being 0.0182, I guess, because that's essentially dividing by 10. And if it was the opposite, the algebra would be a little bit more difficult, but not much. It's just you would have to, so if the base was 0.1 and we were trying to find how much acid you would need, you'd have to still multiply both sides by the acid, but it would just be that unknown value, and you would divide both sides by the 0.182. So if that would look like, so if we had 0.182 was the ratio, and actually, hold on, but the base was the thing that was 0.1. We would multiply both sides by the acid and divide by the 0.182. And so that way the 0.182 cancels out over here and just leaves you with the acid, and the acid over here cancels out, and so you would have 0.1 divided by 0.182, and that would be equal to the concentration of the acid. So it's just essentially one extra thing of algebra if you were looking for the other part. All right. Any other questions about that? All right. So then the next group here, thermodynamics, be able to use the change in Gibbs free energy equation and understand the implications of the sign and magnitude of Gibbs free energy. That will be the same kind of question that you saw in the last exam, And I believe I had a big enough pool of questions for that type of question that I just stuck the pool in there again. So it really is just using this equation, being able to solve this equation, understand the different parts, and figure out if the reaction is spontaneous or non-spontaneous based on what you get for delta G. Let's see, be able to calculate the standard free energy of the formation of a reaction.
Dr. Decker?
Yes.
Yes. Could I ask you a question about the delta S? It was a practice problem in our preparation. You don't have to, if I don't want to like spoil some of your questions that you've asked us, and just ask in question 5 on the practice exam, what is the delta S for this reaction? It just gives us the reaction. Could you just help me understand what I missed it? So I was just wondering how to do that, just given the reaction.
If I give you delta S, and I just give you the reaction.
You didn't give us a reaction. It was solve for delta S.
Oh, solve for delta S.
Yeah, and it gave us this specific gave us Cr2O3 solid plus carbon monoxide. 3 carbon monoxides goes to 2. I think that's chromium. I'm not sure. 2 chromium and then plus 3 CO2. And it
so
says
I did
solve.
give you a chemical equation.
Correct.
So with that type of question, I expect you to use the thermodynamic data from the back of the book.
Okay.
So here in Appendix G, we have...
and then it's just products minus reactants?
Yes.
Okay. And on that, but that says it's an S naught. Sorry, class, if I'm holding you up.
No, it's
this
fine.
says it's an S naught. And so I was just wondering if that's different than delta S. Is that, you see what I'm saying?
Yeah, I see what you're saying. So the S naught, that is the standard entropy value. You use that to find the change in entropy.
Okay.
So it is different than the other two because it doesn't have that delta, but you still use it in the exact same way.
Okay. Okay. I think I was just tripped on the not sign.
Yeah, the not sign is just showing you that it is at standard conditions.
Okay.
So any question like that I ask you, if I ask you to find delta S, and I just give you a chemical reaction like that, you should go to the appendix, look up the S values here, and use those in the same type of equation, products minus reactants, and that should give you the delta S for that reaction. Well, not should, it will. It will give you the delta S for that reaction. And it's the same type of thing that it's talking about here, actually. So it says be able to calculate the standard free energy of formation for a reaction. That's the same thing. It's just this one is specifically talking about the Gibbs free energy instead of the entropy value. So that would be saying using these values here. Stop, I'm not trying to highlight. So the delta G of formation here, you would use those values, products minus reactants, times their coefficients. And you would solve for delta G for that reaction.
And delta H is the same way, you just find those values in the back?
Yes, it would be, but you won't be doing that for the final.
Okay.
But yeah, if you had to do it in some other exam, it would be the exact same thing. But you won't have to do that for this one. The only possibility would be calculating it for delta G. Just trying to limit the number of things that you're going to be studying. So the next one there, be able to calculate the free energy under non-standard conditions. This is just being able to use this equation. Oh, let me see, if I remember this, I believe it is plus RT ln Q. You can double check me on that, but I believe it is plus RT ln Q. I get the pluses and the minuses mixed up all the time. It could be minus RT ln Q. You should go double check me on that. But essentially being able to use this equation is all that's saying. And so the only thing that's really different here is being able to figure out Q. So I would give you all the data that you need to find Q. And remember, Q is the same as the equilibrium constant, just not necessarily at equilibrium. So it's products over reactants with the them raised to their coefficients. And so I will give you the actual concentrations of those things in the problem. It'll just be up to you to figure out the rest. And unless I'm just totally misremembering, I don't believe I ever put in a problem where you would have to calculate both the standard Gibbs free energy and everything else. If I'm remembering correctly, I just went ahead and gave you the standard Gibbs free energy, I believe. So you would have this, you would have the non-standard concentrations that you could plug in to solve for Q. I would give you the temperature, and so it would be up to you to do the algebra, essentially, to work out what the the non-standard free energy is. Let's see. And then the last one here is, for this chapter anyway, be able to convert between standard free energy and the equilibrium constant. So this was, what was the form of that equation? This one I think I will have to look up. So I want to say it was something like K is equal to E raised to the delta G over RT or something like that. But I think I'm misremembering something in there. Let me double check. I wonder if I could find it in here quickly. Somebody have it there? Delta G is equal to negative RT ln K. Thank you. So I think I did have that correct, except for the, I think there's a negative there. I believe that's how that would work out. Yeah. So that particular point there is just essentially saying know how to solve this equation. So if I give you the equilibrium constant and ask you to find delta G, there should be a naught there. You should be able to solve for that, or if I do it the other way around, if I give you a delta G, you should be able to solve for K. Either way. And so I would have to give you the temperature as well. But you know R because R is a constant. So those last 2 points there are just really know how to use this equation, know how to use this equation. Electrochemistry, be able to identify oxidation and reduction based on oxidation numbers. It really is just as simple as it sounds. If I give you a reaction and ask you to tell me what is being oxidized and what's being reduced, you should be able to use oxidation numbers to do that. Let's see. I will not have you balancing equations, by the way. That is not on the exam. The next point there, be able to identify the anode and cathode of a cell based on the oxidation and reduction of each half cell and find the cell voltage. So essentially, if I give you a chemical reaction, so like say, for example, maybe we have this. So as far as I'm aware, that is a proper and balanced redox reaction there, electrochemical cell, that I have written out. So if I give you something like this on the exam, you should be able to look at this and identify what's the anode, what's the cathode. In this case, the iron is the anode because it's being oxidized, because it goes from 0 to +2. And that's an oxidation. And the lithium here is being reduced. It's going from +1 to 0. And so that is the cathode. So you should be able to identify this is the anode, this is the cathode, and you should then be able to go to the table. If you go back up here, go to, let's see. Here they are, standard electrode half cells. And you can find iron going to iron 2 plus, maybe, there it is. So there's its half cell voltage, and you can find lithium, there it is. And so you can take those two, cathode minus anode, I won't work that out right now, but you could take the cathode value minus the anode value and get the cell voltage. Any questions about that?
Dr. Decker?
Mm-hmm.
On that note, I understand what you're doing here. I don't know if I read it in one of your PowerPoints or one of our discussions. The one that is more likely to be the higher the number, is that the cathode usually? I don't know if that, like if zero is higher than -0.447, so 0 would be your cathode. Am I just making something up?
No. So if you're asked to find a working cell, so you want a cell that will have a positive voltage, the anode is always going to be lower on the table than the cathode, so the cathode would have a more positive value. That is correct. That is correct.
Okay, but in this situation, giving this equation, we would have
this would not be a
working cell. Say that again.
I think what you're getting at here, sorry to interrupt you, but yeah, the cell as I have it written here would not work.
Awesome. Okay, that's what okay, thank you.
Yeah, the lithium wants to be the anode, but we have it as the cathode in this situation. And so it would work in the opposite direction.
Okay.
So this direction would be spontaneous.
I have one last question. Sorry, guys. On this note, if you have two negatives, that's addition, correct? Like so, if I had the cathode minus the anode, and the anode is a -0.447, that would be a plus 447.
So just talking about doing the math on that?
Yes.
Yes, so this would end up being -3.04 minus, what was the iron?
0.447.
Yeah, so it was -0.447. So you would end up adding.
Okay.
Because it is cathode minus anode. So you'd be subtracting a negative number.
Okay, thank you.
Which would be adding. So this would end up being a very non-spontaneous reaction, because negative 2.5 volts, that's really, really bad. A battery with 2.5 volts as its voltage, that's a decent battery. Like that's a 50% more than a AA. So having negative 2.5, it's really not going to work. Alright, so then the last one here in the electrochemistry, be able to find the non-standard cell potential. That is just, you could, if you wanted to, you could cross that out and say, be able to use the Nernst equation. If I remember how to spell Nernst. I think that's how you spell Nernst. So use Nernst equation. So the Nernst equation, and again, I'm probably going to get my negatives and positives mixed up here, but I believe it was the E cell at non-standard is equal to the standard cell potential minus 0.0592 volts over N log base 10 Q. Again, I think it is correct that it's negative 0.0592. But yeah, I would encourage you to double check just to make sure it's not plus 0.0592 volts. There's something about the last couple chapters here that I always get the negatives and positives mixed up in their equations. Thank you, Melissa. Malik, to answer your question, no, you will never flip the sign on a voltage from that table. The voltages in the table there are what you're going to use. The fact that one of them is going the opposite direction as what's written on the table is taken into account in that equation that we use. So if we were not taken into account, we would actually have a completely different equation. The equation would be the standard reduction potential plus the standard oxidation potential, in which case we would need two different tables. But we've taken that into account with our equation. That's why we do cathode minus anode, because we can just use one table. We don't have to worry about flipping signs. We do not have to worry about multiplying by values either. And if you notice here, the lithium, we only have one lithium that is reacting on the reaction in the table. But then on our reaction here, we had two. Doesn't matter. We do not change the numbers from that table. We always just take the numbers directly from the table and use them in our calculations. Will the final replace our lowest test grade or anything of that sort? We can talk about this once we finish going through the stuff here. I'd rather get this finished while we're going, and then we can talk about that kind of stuff. So the Nernst equation here, the non-standard cell potential is equal to the standard cell potential minus 0.0592 volts over N log Q. So this is very similar to what we did up here, finding the non-standard free energy. Or actually, that was this one. So I would give you any information you need to solve the Nernst equation. It would just be your job to figure out where everything goes in and do the algebra. Probably the only tricky thing on this one, if you're comfortable with finding Q at least, the only tricky thing is that N value, the number of electrons. Just remember that you can use the half cells. So for our particular reaction, we had iron 2+, which had 2 electrons being transferred, and we had lithium, which has 1. So the smallest number where both of those could be the same is 2. Where you could transfer the same number of electrons was 2. So that would be N for that particular reaction. Okay, boy, my paper's getting messy. So then the last chapter here, the nuclear chapter. First thing there, be able to write nuclear equations for the 4 types of radioactive decay: alpha, beta, positron, and K capture. This will be the exact same style of question that you had in the previous exam, where I give you the parent nuclide, tell you the type of radiation or the type of radioactive decay that's going to happen, and then you tell me the daughter nuclide. You give me the symbol, the mass number, and the atomic number, the number of protons. And if anyone wants to do an example or two with those, we can do that. But before we do that, the last thing here, be able to identify more or less stable isotopes based on the number of protons and neutrons. Again, it's the exact same style and kind of question as the last exam. The thing that I'm looking for here with this is taking into account odd versus even. So do you have odd numbers of protons versus even numbers of protons? Do you have more than 83 protons? Because even if you have even numbers of protons and neutrons, if you have more than 83 protons, there are no stable isotopes bigger than that. Bismuth is as big as it gets. And so if I give you something like a polonium, which has 84 protons, and both the protons and the neutrons are even, and so you might think, oh, even numbers, that means it's stable. No, because it has more than 83 protons, and so it's not going to be stable. And then also, if you have more protons than neutrons, that is not going to be stable either. So that was one of the ones that I think tripped up a lot of people, was one of the examples I gave. I think you had 44, it's either 44 or 48 protons in the example that I gave, and only 40 neutrons. And so you had even numbers of both, but even with the small molecules or small atoms, you don't ever have more protons than neutrons. So even those smaller ones where the ratio between them is at or really close to 1-to-1, you're never going to have fewer neutrons than protons. So those are kind of the 3 things you need to watch for. Technically, you can watch for the magic numbers as well. All the magic numbers are even, though, so you get the same thing if you're just watching for odd versus even. So make sure you know how to figure out how many protons and neutrons there are in a nucleus. And if you have even numbers of both, that's a good sign that it's stable. But then at that point, you need to check and make sure that you don't have more than 83 protons, and make sure that you have more neutrons than protons. I'm not going to pull a fast one where it's like, oh, there's 44 protons and 42 neutrons. It's like, is that enough neutrons? Like, no, I'll be very clear. It's either, if you have fewer neutrons, that is never going to be stable. And I will give you more than enough neutrons to where you'll be comfortable saying, okay, that's more than enough neutrons to hold that thing together. I'm not going to pull a tricky one like that where I put it right on the border of maybe that could be stable, maybe it won't. It's never going to be stable if you have fewer neutrons than protons, though. So let's see. I think that's everything you need for that that kind of question. Would anyone like to do a nuclear equation or two? Okay, actually, let's, instead of writing it on that Word document, let's just do that here. Okay, I'm going to make something up here. Anyone have a favorite kind of radioactive decay they would like to do? Or maybe a least favorite, where they're not sure what happens? K-capture? You can do K-capture. Let's say... I have no idea if this thing will actually do K-capture. Let's see. Let's say we have rubidium. Let's see if it's capturing electron. Okay, let's say we have rubidium. Rubidium 82. Why not? So rubidium 82 undergoes K-capture. So if you have a K-capture, what that means is that you're going to gain an electron. You're sucking in one of those electrons from the 1s orbitals. For some reason, nuclear chemists like to call those K electrons. Not entirely sure why. I looked it up at one point, but I don't remember what the reasoning is now. But anyway, K-capture. Oh, and we lost Grace. Well, maybe she'll come back later and watch this. So we have the electron that is captured by the nucleus. I'm going to go ahead and write in the atomic number for rubidium. It's number 37. So the thing that we're going to make has to have the same mass number, because the only thing that changes the mass number is alpha decay. Alpha decay is the only one that actually causes the nucleus to lose mass. So the thing that's going to change is the atomic number. So again, there's two different ways we can work this out. We could think about it in terms of what is the electron going to do? What is it going to turn into something else? You are adding negative charge to the nucleus. What that means is that negative charge is going to go into a proton and turn it into a neutron. The reason we know that is because we can't take an electron and put it into a neutron, because then we would have a negatively charged particle in the nucleus. We'd have some kind of odd negative neutron. That's just not physically possible, at least as far as I'm aware. But if we can take something that's positive and add a negative charge to it, that will neutralize it in a sense. And so we can add an electron to a proton to make it a neutron, which means that the atomic number here is going to decrease by 1. Because remember, the atomic number is the number of protons. So we lost a proton. It turned into a neutron, and that will change this into krypton. So your answer on the exam, you'd have 3 different boxes. And if I remember correctly, I think they were arranged chemical symbol, mass number, atomic number, I think. And so it would be CR 8236. let's say we wanted to do does anyone have a preference of let's see, beta or alpha? Anyone have a preference of the two? Beta, okay. Then let's say we have protactinium 238. Somehow, we made some protactinium 238. Don't ask me how, I don't know. But we have some protactinium 238. That has an atomic number of 91. It oh, that one looks weird. That's odd. So it undergoes beta decay, which means that one of the particles that is produced is an electron, which again sometimes is written just as a beta symbol. So this is a product. We are trying to figure out what the other product, what the other daughter nuclide is for this process. Again, because alpha decay is the only one that changes the mass number, the 238 is going to stay the same. The electron that is leaving had to come from somewhere. If that electron was produced by a proton, so if we had this positively charged thing and the electron left that, so the proton spit the electron out, what we would be left with would be a doubly positive proton, because it lost even more negative charge. And that's not possible. We can't have a doubly positive proton. But what we could have is a neutron that spits out that electron and becomes positive. So we have something that was neutrally charged, it loses negative charge and therefore becomes positive. And so what we're doing here is we're turning a neutron into a proton. Now, if you don't want to think about it in terms of one particle turning into another particle, you can always think of it in terms of the math. The atomic numbers on the left side of the equation are always going to equal the atomic numbers on the right side of the equation. And that will only work if we have 92 as the atomic number of the other daughter nuclide. We have 91 on the left, we need 91 on the right. 92 minus 1 gives us 91. And so if you look for atomic number 92 on the periodic table, that is uranium. So again, on the exam, it would be something like U23892. That's what you would put in there. The symbol, the mass number, the atomic number. The symbol does need to be in the proper case, by the way. It is case sensitive, so don't put a little u. It would be a capital U. All right. Any questions about that? And again, you should be fairly comfortable with questions like these because they were the same questions that you had in the last exam. Although I know most of you are not terribly pleased with that exam, but hopefully you're slightly less pleased with that once I went through and checked the questions. How important are sig figs in your answer? Not terribly. As long as you're not giving it 10 digits or anything like that, you should be fine. I think the usual rule of thumb, 0.3 or 4 sig figs is usually good. So, Stephanie, I might have fixed that one for you. I seem to remember somebody being fairly close, and I went back through and gave the points back on that. Usually what I do with those numeric problems is like if the answer is 240.1 or something like that, I will usually say plus or minus 1. If the answer is like 0.252, then I will say plus or minus 0.02 or something like that. I give it a range to accept answers in, and I usually try to make that range somewhere around 1 to 5%, something like that, of the value of the answer. So I do give it a range. Some of the questions where there really is no possible way to get a different value, unless you did something wrong, I don't give it a range. So I'm trying to think of an example of that. Like if there were a question where you were trying to find the correct number of protons in a nucleus, like there's not really a range for that. I mean, those are individual particles, and so there's not really an acceptable range. But if there's calculations being done, or maybe you did the rounding differently than me, or something along those lines, I do try to give it a range of possible answers, and I do go back in and check those as well. And I'll double check that for you, Stephanie. So is there going to be a curve on exam 2? Yeah, I don't think I gave as much partial credit on exam 2 as I did on exam 3. So I can't say for sure if I will go back and give a curve on exam 2 until I go back and do the partial credit the same way that I did for exam 3. I was a bit more generous in exam 3 on partial credit than I was on exam 2. So I'll go back through exam 2, try to give some more extra credit, or not extra, partial credit on questions there. And depending on what the scores are, we'll see. So the homework, so the lowest grade on the homework assignment dropped. I'm not dropping the lowest homework score. Was, well, so homework 14. I'll have to go back and look what was going on with that homework. But the homework scores are not going to be dropped. I've been thinking about exam scores. I guess speaking of the homework there, what day was the homework set to be due? It's set to be due tonight. Yeah, I guess the final was originally due tonight. I guess I can extend it a little bit. The reason I hesitate to do that is just because, like, I don't want you to put it off too much, so that you spend all your time on the homework and then don't spend time for the final. Um, so let's say until Thursday. So I'll extend the homework to Thursday. So you have a couple more days, and you'll still have a couple days where you should not be working on homework. You should be studying for the final and completing the final Thursday and Friday and Saturday at the very, very, very latest. So let's see. So exam 3, I want to say, once, obviously before I went through and checked everything and gave partial credit and corrected questions that were incorrectly graded, exam 3 was really rough. I think there was one student that I think before I went through and checked had a score in the mid 40s, and after I went through and checked everything had a score in the upper 70s. So there was a huge swing, a huge swing in the scores before and after I went through and read through and checked the exam. And I would just like to apologize for that taking so long to get done. If I'm being perfectly honest, I have been swamped the last couple weeks. And I don't say that as an excuse. It's more of just as an explanation. I think maybe a few of you know a little bit about what's going on in my personal life, but I'm a single parent, and I have triplet 4-year-olds, and they are at my house from Wednesday morning until Saturday evening, and it is very difficult for me to get anything done when they're here. They do not like they'll play on their own to a certain extent, but when there's 3 of them, even if 2 of them are playing on their own to a certain extent, the third one wants to have some attention paid to him. And so really the only time I have opportunity to work on stuff is like starting at 9 o'clock in the evening on those days, and there's not really much time to get stuff done at that point. And so for those days, I can't really get anything done, and so then Saturday evening through Tuesday evening, I'm trying to get 7 days worth of work done in 3 days. And I have not been terribly successful at that. So I apologize for it taking me so long to respond to emails over the weekend. I know some of you are really freaking out about your exams, and I'm sorry that I left you in the lurch like that for so long, stressing out. I know that didn't help with all the other stress that's happening. And again, I'm not telling you this as a woe is me or anything like that. I'm just trying to explain. But I did get to all the emails yesterday, so if you emailed me over the weekend, you should have gotten a response yesterday. So all that to say, when I did finally get to going through those exams and increasing scores on all that stuff, the scores did jump up a lot. I think now the average is mid to upper 70s. I want to say it's either a 74 or 76 or something like that. Ended up being the average on that. So, and like I said, I have not gone back through exam 2 the way I did exam 3. I was a little bit more harsh on exam 2 just because it was, it's a new situation, and I was thinking that all my classes would do better on those exams, but now that I've given, I think, 5 online exams at this point with classes that were on campus before, like I said at the beginning, it's a learning process for me too. I'm realizing that some of the questions either could have been worded differently, or I could grade them differently, or could have worked them out slightly differently. And so I'll go back through exam 2 and give, at the very least, more partial credit. I probably won't find questions that were actually correct, but were marked as incorrect in the first place, although that's possible. But at the very least, there'll be more partial credit. I've been also talking with other professors about what they're doing in their classes that were on campus but are now online, obviously, since everyone's online. Some professors like didn't even do their final, which in retrospect, I think if I had had the opportunity to know what I know now a couple weeks ago, I probably would have considered that. I would have considered just completely skipping the final. Now that I've already written the final, and you all have studied for it and everything, what I'm going to do is if you score better on the final than any of the previous exams, the score you get on the final will count for both. So it will, if you got a 65 on a previous exam and you get a 73 on the final, the 73 will count for the final and for that lower exam. I can do a mic drop now. I can make it sound like a mic drop. So there you go. No, I'm not. I wouldn't consider myself a hero, and I'm also not wearing a cape. I am wearing clothes today, though. I will admit I have done these calls in my underwear before, which is probably TMI. Although I don't know if I've done this specific class. I've done a class before. Anyway, so that's what I decided to do for this, because it has been incredibly stressful for everyone. Like I said, including myself. I can understand at least partially how you are feeling. So that is what we're going to do for the final. It will count. And by the way, if for some reason you do worse on the final than any of the previous exams, which is possible, you will not do, the lowest score you'll get would be the lowest score that you've gotten on some previous exam. So if you have done really well on all the exams at this point, you don't have a whole lot to worry about on the final. So I don't want it to be just something amazing for the people that have struggled on a previous exam. If you've worked your backside off and you've gotten A's or really close to A's on all the previous exams, you can relax a little bit for the final. Obviously still get the homework done if you haven't done that yet. But I know there are a couple of you that even with the online exams you still did really well. And so if you've gotten really good scores, you still have to take the exam. You can't just do nothing. That won't get your score replaced. But if you take the exam and you don't do quite as well on it, the worst you can do is your worst exam grade up to this point. All right. Questions about that? No questions? All right. I think that's everything that I wanted to talk about. I'll send out an email with the details on that as well, just because there's actually we have quite a few people on at this point. So there's actually a majority of you here. But there's still a few people that were not able to make it this morning, and I'm sure they would like to know about the final exam as well. So I will send out an email with the details on that. Yeah, Monday you should know, Malik. Monday, they want me to have the scores in Monday by noon, and I'll try to have them in Monday by noon. It's possible I could have them before then. Might be a little bit later. I honestly don't know at this point. I have so much grading to do. I could still be grading Monday Monday at noon. It'll depend on how quickly I can get through it. But the absolute latest that the grades can be turned in is Tuesday at noon. Like if I don't have my grades turned in Tuesday at noon, it's not just some random, excuse me, random administrative assistant in an office somewhere calling me, like it's my boss calling me and saying, you need to get those in right now. So that is the absolute latest, would be Tuesday at noon. And usually what I do, just for those of you that have not had me before, usually what I will do is I will put a letter grade in Blackboard earlier. So the letter grade in Blackboard will most likely be in there Monday by noon at the latest. That letter grade in Blackboard is not necessarily your final grade. If it's a final grade that you're happy with, then yeah, it is. But if you have done the calculations and you think that you earned a B, and then I put into Blackboard that you have a C, and you think, okay, he did something wrong. Just because I put a C into Blackboard, that is not where the final grades are turned in. Those are actually turned in elsewhere. So if you think that I put in a wrong score somewhere, if you think I made a mistake, you can email me. We can talk about it. Maybe I did make a mistake. It would be the first time. The final grades are actually turned in my TCC. There's a separate place. So that score I put into Blackboard, that is really just to tell you. That's all it's there for, is to tell you what your grade is. That is not actually what goes to advising or whoever that actually makes the grades permanent. That's in a whole different place. So I will put the grades into Blackboard earlier, and then the final grades will be turned in Tuesday, but you should have the grades before then. Sapling. So to recap, sapling is due Thursday. We'll just say Thursday at midnight, just because that's convenient. So you have a couple more days to work on that. The nuclear lab, I don't think we talked about the nuclear lab. Let's just go ahead and make it due at the same time, just for ease, I guess. Practice exams do not count towards the grade. They are just there to help you prepare. Yeah, okay, so lab, yeah, so Melissa's saying lab by then. If I have the date set for the end of the week, then yeah, just get it turned in by then. If the due date is earlier than that. I think I've talked to most of you about this, but for most things, up to this point anyway, I've been more lenient on those due dates. Now that we're at the end, I have to be a bit more strict, because they do have to get turned in so I can grade them, so I can get their grade turned in. But as long as they are turned in before Saturday, I should be able to get those done. But again, I don't want you working on stuff at the very last minute when you really should be preparing or taking your final. It should be, yes, Stephanie, those should be the only things left. Is if you still have sapling to do, you should get that done. The nuclear chemistry lab, there is the Word document that I sent out that has the data on that, and then the final, which is due Saturday at midnight, but again, I would highly encourage you to do it before then. Friday evening at the latest would be my suggestion. And one quick thing about the nuclear chemistry lab, because I've had some people asking about it. The percent transmission, it can go above 100%, just because of the weirdness of radioactive decay. Like for the gamma emitters, like it might have started at like 140 decays per minute, or however it's measured there, or counts per minute, I think is what it is. And that was jumping all around. Like it was up and down and up and down and up and down and up and down. And so I was trying to pick a middle ground of where the counts per minute were. And as I would add layers to it, sometimes it seems like it would just go through like a 30-second period or so where it just, by random happenstance, was giving off more radiation than it was a minute ago. And so it might jump up to 150. And that just happens. I mean, that it is a truly random process, the decay of radioactive isotopes. And so you can have, a minute or 2 minutes or 5 minutes where the average count per minute is about 140, and then for the next minute it'll be higher. It'll be 150, 160. And so when that happens, like I didn't try to goose the data, as they say. I didn't try to make it so it was nice data. I actually took the data as it came out of the Geiger counter. And so this would be a greater than 100% transmission, and that's perfectly fine. Just put in the original counts as your, I guess that would be the denominator, and the counts at that number of layer as your numerator, so it would be 150 divided by 140 times 100% would be your percent transmission, and that's perfectly fine. That was mainly with the gamma, and I think a little bit with the beta as well. But the gamma emissions are so hard to shield yourself from that, as you might notice when you look at that data, it really didn't get shielded at all.
Well, I have a question on this lab. For the alpha, because we're supposed to graph all of our data, but on the alpha particles that are still getting through, it's like less than 1%. And on the lead, it's like 0.018, like all the way.
Mm-hmm.
So that's
for
gonna be tiny on the graph.
let me see if I have that graph here.
And then also another question, if it's really low like that, how do you want us to do it? And then if it's, higher, because some of it's like 106%, and so do we just go off the graph for that?
You could just put it at the top. Yeah, so you could just put a data point right at the top of the graph. If you wanted to try to put it a little bit higher, that's fine too. Just do your best. I'll be able to tell what you're trying to do there. But if you're going down to, so like the alpha emitters with the lead here, we're just like, it just immediately drops down to background.
Mm-hmm.
Because there's always a certain amount of background radiation, and it seemed to me that it was about 5 counts per minute, because no matter what I did, there was always a little bit there. So the graph of this one, you would have, it's just essentially just goes immediately to 0 and just stays there. And that's what I would want to see on your graph for the alpha emitter there. Is when you're at 0 layers, you're up at 100, and then when you get to 1, it's just all the way down at 0. So you would have the line right here. So you'd have one data point here, because at 0 layers, you're at 100% by definition. Excuse me, by definition, because there's nothing shielding. And then when you get down to 5, it's just, you're down here, and it just stays down here for the rest of the time. So you would have that. I know it kind of looks like that was going up. That was just my hand drifting as I was trying to draw a straight line. But then the rest of these, you should see something closer to like a gradual decrease in the percent transmission. They do eventually, like the beta emitter here does eventually get down to the same place as the alpha emitters. It gets down to the background radiation, but the gamma does, which is just, it's crazy to me. It truly is crazy to me. You have, that is nearly a ½ inch of lead, and you're still getting more than 50% of the gamma rays getting through that. That is just nuts. So that one would be something more like this, I guess. The gamma radiation. But that's what I would expect from those. And so for these up here, where you do get more than 100%, so it's like the gamma goes from 150, 150, 170, so you would just have 100%, 100%. If you wanted to put this one a little bit higher, you could, or if you want to just leave it at the top, that's fine as well. Eventually, it looks like there's one where it gets down to like 90%, but the majority of them are just right up here, where you're getting all of the gamma rays through the paper. The paper's not really shielding it at all, and the aluminum foil was pretty much the same way. The only thing that got close to shielding the gamma rays was the lead. Any other questions about that? I wish we could have done that lab in the lab. It's always fun to work with Geiger counters and radioactive materials. But oh well. I wish we could have done all the labs in the lab, but that one especially. That one is fun. Okay. Well, if there are no other questions, are there any questions that were in the chat that I didn't notice? Guess not. All right. Well, we've been on here a couple hours. Time well spent, I think. Good luck with your exam and your homework. And I guess I might not talk to you guys ever again. That's kind of sad to think about. So I guess before I let you go, thank you all for dealing with this crazy semester. It has been kind of nuts, and you all have handled it as well as I think you could have. So good luck with the class, good luck with the rest of your life, and I hope that I'll see you all again. If you have the chance, if you're at West Campus sometime, once all this madness is over, swing by my office and say hi. I would appreciate that, and hopefully I'll remember your name. If I don't remember your name, don't be too mad with me. I am genuinely terrible with names. But I hope you come by sometime and say hi. And if you can think of it, do fill out the course evaluation things with my TCC. They're on the Blackboard site. I did not just butter you up just now and then ask you to do that. That was not my intent, although it kind of came out that way. But please do complete those at some point. It's been a crazy semester. Feel free to talk about how you would do things differently. That is perfectly fine. You do not have to be nice to me in that, although I would appreciate you being constructive instead of really anything else. But please do that if you have the time and you think of it. But otherwise, have a great finals week, and I'll talk to you all later.